Hello, good morning. Here we'll discuss the last topic of Laplace transform, which is named as convolution. Convolution theorem. We were discussing certain properties of Laplace transform, in which we can add one property, which is called convolution theorem. Before moving to define convolution, I'll give the reason for discussing that. As we know, the Laplace transform of f of t into g of t is not equal to Laplace transform of f of t into Laplace transform of g of t. It is not true. Where by f of s I mean Laplace transform of f of t, and g of s is considered as Laplace transform of g of t. So Laplace transform of this product of functions is not equal to this. When we discuss linearity, I already mentioned this. So naturally, one question will arise: what is Laplace transform of product then? What is the formula for that? Like the product rule in derivative, uh, it is not in derivative of f of t into g of t is not equal to f dash of t into g dash of t, but it is some other formula. Similarly, here also the natural question is what is the formula for this? But the answer to that is not easy, so we are not going to discuss that. Whereas other question may arise is this is not a Laplace transform of this product, but f of s into g of s is Laplace transform of what function? If it is not Laplace transform of this f of t into g of t, then it is Laplace transform of which function? Now, for this, the answer is f of s into g of s is Laplace transform of convolution of these two functions, which is denoted by f of t star g of t. The star denotes convolution. We know between two functions we can have different operations like f of t plus g of t. It is addition operation. Like this, subtraction will be there, multiplication is there, f of t into g of t, and composition operation is there. We can define f of t composition g of t. Similarly, now we are going to discuss another operation, which is f of t star g of t. This operation is called convolution operation between f of t and g of t. The importance for this is f of s into g of s will be the Laplace transform of that convolution function. Now let us define that convolution. It is defined using an integral. It is defined as h of t equal to f of t star g of t, or simply f star g, which is equal to integral 0 to t f of tau into g of t minus tau d tau. You can see tau is a variable, t is another variable. We are integrating with respect to tau. So after integration, the resultant will be a function of t. That function of t is called h of t, which is the convolution of f of t and g of t. Okay, for example, suppose we take 1 star 1. 1 is constant function. Here f of t equal to 1, g of t equal to 1 are constant functions. Then convolution between them is integral 0 to t f of tau, which is 1, into g of t minus tau, which is also 1, dt, which is equal to t. Convolution between 1 and 1 is t. Okay. Whereas what is convolution between t star 1, convolution between t f of t equal to t and g of t equal to 1. You can see it is integral 0 to t tau into uh, g of t equal to 1. So g of t minus tau is uh, t minus tau is also 1 d tau, which is equal to tau square by 2 from 0 to t equal to t square by 2. Okay, you can see uh, if f of t equal to 1 and g of t equal to 1, f of s will be, which is Laplace transform of 1, which is 1 by s, and g of s is also Laplace transform of 1, which is 1 by s. Then f of s into g of s is equal to 1 by s square, which is Laplace transform of t, that is equal to 1 star 1. So product of this will be the Laplace transform of uh, convolution. Okay. Similarly, here you can see f of s will be Laplace transform of t, which is 1 by s square. F of g of s is equal to Laplace transform of 1, which is 1 by s. Then the product is 1 by s cube, which is Laplace transform of what? We know 2 by s cube is Laplace transform of t square. So 1 by s cube will be Laplace transform of 1 by 2 into t square, which you can see the convolution between t and 1. So this is an illustration of our what is a convolution theorem. Okay. So using this, you can find inverse Laplace transform of certain functions. Okay. If you want, you can try to find convolution between uh, e raised to t and e raised to minus t. What is convolution between these two? This will be integral 0 to t e raised to t into e raised to t minus tau, so e raised to tau into e raised to t minus tau d tau. This is equal to integral 0 to t. You can take e raised to t outside because integration is with respect to tau. E raised to t into e raised to 2 tau d tau. Integration from 0 to t. Okay. So is equal to e raised to t into e power 2 tau over 2 limit 0 to t. That is e power 3t, sorry, e raised to t into e power 2t or 2 minus 1. This is equal to e power 3t by 2 minus e power 2. This will be the convolution between them. Similarly, you can find convolution between any two functions. You can see questions in your exercise textbook of in the exercise of your textbook. Okay. Now, using this convolution theorem, let's find inverse transform of certain functions. I'll give one question. Using convolution theorem, find inverse transform of inverse Laplace transform of 1 by s minus 3 into s, or s into s minus 3. So the method to do this is, you want to consider this as an f of s into g of s. Inverse of f of s into g of s you can predict using inverse transform. This you can consider as f of s into g of s, where f of s is 1 by s minus 3, g of s is s. So f of s equal to 1 by s minus 3 implies f of t equal to L inverse of f of s. L inverse of 1 by s minus 3, which is equal to e power 3t. Whereas g of s equal to 1 by s implies g of t is 1. Therefore, L inverse of f of s into g of s equal to e power 3t star 1. You can see this is commutative operation. So 1 star e power 3t and e power 3t star 1 both are equal. You can do in any order. Okay. Anyway, this formula we are getting from convolution theorem. Okay. This is equal to integral 0 to t e power 3 tau into 1 d tau. This one is g of t minus tau. G of t is 1, so g of x is also 1, g of anything is 1, g of t minus 2 is 1. Okay, so 3 tau over 3 you get e power 3t over 3 minus 1. Okay, this is the formula. This is the function, inverse transform of given function. Okay, now this will be 1 minus 1 by 3.